Hello, these are notes for anyone taking Algebra 1, Semester 1. And just want to start with chapters 1 and 2 and a little bit of vocabulary. We got some key vocab words. You should have a copy of the notes and just be filling in the blank areas. The first vocabulary would be natural or counting numbers. And those are, basically the same, natural or counting. They call them the same thing. And what those are would be the set of numbers 1, 2, 3. You put in a 4, 5, 6. Those are all numbers that are just starting at 1 and counting straight up. Whole numbers, no decimals, no fractions. So if I gave you example 1 here, which of the following represents a natural or a counting number? Is 0 one of the ones that is listed here? And that would be big fat no. Not that one. What about -5? Well, -5 does not start with 1 and go up. -5 is below 1, so that's also a no. 8, 1, 2, 3, 4, 5, 6, 7, 8 would be one of my groups there. That's going to be my answer. 0.67 is not a natural number or a counting number, definitely. Now, whole numbers, on the other hand, are almost the exact same thing. Whole numbers exactly the same, except they start with 0. So whole numbers, 0, and then 1 through whatever. So a 0 added to all the natural numbers. So tell me 3 examples of a whole number not given above. Try it, see if you can write in 3 numbers that are examples of whole numbers. Hopefully you came up with a couple, but I'll list a few for you. Whole numbers that are not listed above could be like 10. So I'll put in like a 10. Okay, there we go. So 10, maybe a 20, maybe a 25. Those are all whole numbers. As long as they don't have a decimal or a fraction, it's a whole number. Integers, on the other hand, are numbers 0 and all positives or negative numbers. So basically what we would say is the numbers on both sides of 0. You got a 0 in there and you got the numbers to both sides. Now, which of the following represents an integer out of these 4 choices? -25 is definitely a number that doesn't have a decimal or a fraction. It's not B, that's a fraction. It's not C, that's a decimal. And it's not D, because that's going to come out of the decimal. That radical 17 is not a whole number. Now, real number would be all of the numbers on the number line and everything in between. So basically what I mean by everything in between means all fractions and decimals. So any fraction or decimal, anything you could put on this number line, like number right in here, 4.2, or negative 0.5, -2 is a real number. All those are real numbers. Anything you could put on that number line, any places you could put, would be a real number. A rational number is the set of all numbers that can be written as a fraction, and the fraction here being p over q, where p is an integer and q is a natural number. Now the reason that q has to be a natural number is because the bottom number in every fraction cannot be 0, and a whole number might have a 0 in it, so q has to be a natural number. It has to be a number that starts with 1 and gets higher. So rational numbers can be made into fractions. Anything that you can make into a fraction is a rational number. Now let me just move that up a little bit so you can see them a little bit better. Give you some time to make sure you write down rational number in the spaces that are there for you. And let's look at these also 4 choices that are listed here. Just choose the rational number below. Radical 19. If I put radical 19 in my calculator, if I put the square root of 19, I get 4.358. 4.358, and it just keeps going and going and going and going. So that you cannot make into a fraction because it's not a repeating decimal, and it's going to go on forever. Pi, so this is definitely not it. Pi is also not a repeating or not a rational number, because pi does not end either, and it does not repeat. 3.14159, and it just keeps going. 3/4 is a rational number. That is a fraction. Anything that is a fraction, right here, you can see the fraction. Anything you can make into a fraction is a rational number. D is definitely not a rational number because it does not end and it does not repeat. If it's just a repeating decimal, you could make that into a fraction. Fractions that do not repeat are not rational. Some quick notes on integers, just in case you forgot how to add and subtract integers from 8th grade or whatever. We've got just some examples here for you. 3 plus -2 would be -5, because when you add integers with the same signs, you are going to add and keep the sign. So when you see a -3 put together with a -2, those two together have to add them, and you have to keep the sign because they're both negative. It's like putting two numbers together that are on the same team. You're making more of them. So what number plus 7 would equal 10? I would need to have the same sign, so it's going to need to be a +3. Now, you can see when you have a minus here, you've got a couple of choices. This is a -2, and this is a -9, because it really means adding the opposite. So when you have a minus, you could make that a plus -9, and you would have the same sign. Therefore, you added it up and got -11. Let's try this one right here. -6 plus +7. Are those the same sign? No, so let's come back to that in a minute. Let's try this one over here. -23 and -4. Those are the same sign, so you're going to add them together and get -27. Now, when you're combining numbers with different signs, you subtract, and the integer furthest from 0 keeps the sign. You could almost put in here the one that has the biggest number. Now, we don't use biggest numbers because positives are always bigger than negatives, but whichever one has the biggest digit, the largest digit is going to keep the sign. So if this is a -6 plus a +7, you're going to subtract those and get a 1. The one that has a bigger digit is a 6 or a 7. A 7 has a bigger digit, and it's positive, so it's a +1. So 1 would be your answer there. You get these examples down here, -3 and a +9. 9 has a bigger digit, so when you subtract them, it stays positive. 9 and plus -18. 18 has a bigger digit, so you're going to keep your answer negative after you subtract. 3 minus 11 means you've got a +3, you've got a -11. They're different signs, and a bigger digit, the 11, so you're going to get a -8. Here's a couple to try. -12 and +16 is going to give you a +4. 16 has a bigger digit, so 16 is a bigger number than 12. +11 and a -20. Which one has a bigger digit? 20 has a bigger digit. 20 has a bigger number in front of the sign or behind the sign, so you're going to keep your answer negative, and when you subtract it, you're going to get -9. Just some quick notes on integers. You're going to combine integers. When they have the same sign, you add. When they have a different sign, you subtract. Add and keep the sign, subtract, and the one that has a bigger number will keep the sign. What about when you multiply and divide integers with the same sign? That's an easy one. If they've got the same signs, you're just going to keep your answer positive. Same sign, always positive. So negative times negative is +12. Positive divided by positive is positive 3. Negative divided by negative is going to be a positive 9. Negative 8 times negative 7 is going to be a positive 56. Negative 36 divided by negative 4 is going to be a positive 9. Always positive when you have the same sign. And you probably know exactly what happens when you have different signs. It's always going to be negative. Always negative with different signs. Different signs here, you're going to get a negative 54. Positive divided by negative, you're going to always get a negative. It doesn't matter if the 16 is bigger. It just matters that those two are different signs, so it's a negative 2. 12 times negative 2, again the 12 is bigger, but you still have negative 24 as your answer because they're different signs. 11 times negative 6 is negative 66. Negative 48 divided by, you're going to need a positive 6 in there, because it's got to be different signs to get a negative 8. So quick little examples on multiplying and dividing integers. Irrational numbers. We've seen rational numbers, anything you can make a fraction out of. Irrational numbers are numbers that you cannot make fractions out of. You cannot write it as a fraction. And here is the basic, easiest way to remember. It's a decimal that never ends and never repeats. A decimal that never ends and never repeats. Let's fix that for you. Never ends and never repeats. So it's a decimal. We know it's going to be a decimal. It doesn't stop. It doesn't repeat. Now, if it's a fraction, then we know it's a rational number. But if it's a decimal that never ends and never repeats, then you know it's irrational. Irrational numbers. The reason they call it irrational is because you don't really know how much it is. It never ends, so you never know the exact amount. So if we look at these, this is definitely not irrational. Definitely not. 6 is a whole number, it's a counting number, it's an integer, it's all of those. Negative 9 is an integer, and it's a rational number, and it's a real number, but it's not irrational. We know exactly how much negative 9 is. 0 is a whole number. So 0 and negative 9 are definitely not irrational. The only irrational one here would be a radical 2 because you get 1.4, 1, and then you get a bunch of numbers that don't repeat. They're not ending. They never end. It goes on forever. So this is the one that's irrational. Match the numbers with their classification. So if you look at all of these 4 choices, 5 choices, the easiest one to find is probably the irrational one because it goes on forever. Has to be letter E. Now the whole number you could have as not A, but you could have it as B or C. So let's wait and see. Rational number is going to have to be the 3.5 because I could change this to a fraction 7 over 2 and it would be the same as 3.5. So rational is anything I can make a fraction out of. Now there's only one negative number here, and which one of these 3, the whole numbers, the natural, or the integers, could be negative, and that has to be your integer, which is going to be negative. So one of these is a natural number, and one of them, well, they're both whole numbers. One of them can only be classified as natural, and that would be letter B. Whole number is going to have to be the letter C, even though I could have also put B for whole number. That matches all 5 of them up with all 5 answers. So there is next page. Moving on. Okay, the maze is for you to work on. I'll get you started on it right now, give you a few answers here, and then we'll move to the next slide. Evaluate each expression and connect the positive integers that lead you to the finish. No diagonals are allowed. So if I start here and I answer this, I would get a positive 4. So I would continue my arrow this direction. If I go down to here and I add opposite here, that's going to be a positive 14. So I might keep this going here, and this might be positive, I might need to go over here. So eventually you'll find your positive route that will get you all the way to the end down here at the bottom. You're trying to get to this finish line down here at the bottom. So you'll come back to that after the notes is over. That'll be the first thing you do after your notes. All right, a couple things now. In chapter 2, mainly, maybe still some in chapter 1. Numeric expressions contain only numbers, and there are no unknown quantities in a numeric expression. Only numbers. The key thing there, only numbers. So if I have 9 times 2, that's a numeric expression because it has only numbers. Only numbers. Numeric expression. Five times 2.5 is a numeric expression. And numeric expressions can be worked out. A numeric expression, you might even want to write that up in here, can be solved. If I've got a expression that I could actually find an answer to, then I know it's got to be a numeric expression. Example 6, we had a numeric expression because I could actually multiply these two together and get 12.5. So that would be a numeric expression. Example 7, 4 plus 6 is numeric expression because I could get a 10. I can work it out to be a 10. So that would have to be a numeric expression. Example 8 is 8x. Now 8x is not numerical. You cannot get an answer. It's called an algebraic expression because it has an unknown value. That x is something we do not know how much that is. They did not give that to us. So numeric expressions have numbers that you can work out. Algebraic expressions have an unknown value. 8x would be an algebraic expression. Numeric expressions have only numbers in them. They have only numbers. Okay, a variable. A variable is another key word, and it's a letter that represents a number. A letter that represents a number, like we can use X, we can use Y, we can use A, all those. Now, it could also be a symbol. I mean, we could use a star as a variable if we wanted to. Use anything we want. Now, normally, do you see stars? No, you see X, Y, A, B, all those letters. Z, Z, those kind of things. It's a number, letter, or symbol that represents a number. In math, the most commonly used variable that is used, or the most commonly used variable that is used to stand for an unknown quantity is X. The one used the most. However, any letter or symbol can be used, so any of these would work. So the most commonly used variable for an unknown quantity is X. See that the most. You see it the most. When you have a number and a variable next to each other, those two are next to each other, it means that they will be multiplied together. So if you see 8x, like we did earlier, we had 8x. What that means is 8 times times whatever x is. That's when a number and a variable are next to each other. Always is multiplying. Now an algebraic expression consists of numerals and variables. You could have numbers, you could have variables, you could have operations, all kinds of stuff in algebraic expressions. You can see the ones listed down here. These all have unknown quantities in them. So anytime you have an unknown quantity, it's called an algebraic expression. Some unknown letter or number, we don't know what it is. We don't know how much y is, so it's an algebraic expression. Other key vocabulary terms. Simplify. Finding the simplest form, so reducing. So you could also kind of put here reduce. There's another way to reduce. There you go. That's another way to put simplify is to reduce. Sum is the answer when you're adding two or more quantities. We call it a sum. We call it a product when you're multiplying two or more quantities. Multiplying two or more quantities, you call it product. And the difference is when you subtract two or more quantities. You could also say the word quotient when you divide two or more quantities, but these are some other key ones that I have listed. So simplifying, make it in simplest form, reducing. Sum is when you're adding two or more quantities. Product when you're multiplying two or more quantities. Difference when you're subtracting two or more quantities. Now there are some properties in algebra. There's an identity property of addition and multiplication. And here's what the identity property basically says. It says 0 can be added to any number without changing it. If I take 1,000 and add 0 to it, it stays 1,000. It doesn't change it. Adding 0 does not change a number. We call that an identity. It keeps its identity. It doesn't change its identity. Multiplying anything by 1 is also an identity. It does not change the number. 1,000 times 1 is still 1,000. So an identity property is when the number does not change. So you kind of get to see here when I added 0 plus a, you're still going to get a. And a plus 0 is still going to give you a. A times 1 is still a. Here's another a times 1. That's still going to be a. When you don't change the value of the number, that's an identity property. Adding 0, multiplying by 1. So it says write each of the following in the right columns. So these are the ones that we need to write in the correct columns. So is this symbol plus 0 still this symbol and an example of an identity? Did this number stay the same? And that yes, it did stay the same. 9,009 plus 1 equals 9,010. Did this 9,009 stay exactly the same? No, it became 9,010. That's not an identity. Triangle times 3 divided by 3 equals triangle. That's an identity property right there. You multiply by 1. 3 divided by 3 is a 1. 18 divided by 0 is 0. It's not even a true statement. You cannot divide by 0. So, I mean, that's not even a true statement. So it's definitely not an identity. 5 plus 1, adding 1, does that make 5 stay as a 5? No, it became a 6. That's not an identity. X plus y plus 0 is still x plus y. That did not change. That is an identity. Star or triangle or diamond times 0 is 0. That's a zero product property, not an identity property. 3 times 1 stayed a 3, so that is an identity property. So write those on the correct columns. That's where they should go. Distributive property, I call it the rainbow rule. So it's a way of showing a rainbow. It's multiplication, Distributive property of multiplication over addition means multiply every term in the parentheses, by the number outside the parentheses. Should be a 5 right there. Every term in the parentheses by the number outside the parentheses. Every number inside the parentheses by the outside of the parentheses. Here's a little example. If you watch the board, watch over here what happens when I click on rainbow rule, and you can see that the rainbows came in. A times by B gives me AB. A times by C gives me AC. That's called distributive property. We're distributing. You can see here, 5 times x gave us 5x. 5 times 2 is our 10, so 5 times 2y would be a 10y. What would we get here? We would get 3 times 5 plus 3 times 6. 3 times 5 plus 3 times 6. Here we would do rainbow backwards. So you would still get A times B, and you would still get A times C. Notice how they both have an A because the A is outside. The A is being distributed to both terms. The A goes to the B, the A goes to the C. Here the 3 goes to the 5 and the 3 goes to the 6. So it's still going to be 5 times 3 and 6 times 3. You're going to get the same answer you got up here. That's distributive property. If we wanted to show our rainbows, we could show that 3 went with 5, 3 went with 6, A went with B, A went with C, 3 went with 5, 3 went with 6. Those are our rainbows. If we try the one down here, you put in your rainbow, 3 times negative 3 times 2x, negative 6x, remember different signs of negative. Negative 3 times negative 4y, remember the same sign as positive, positive 12y. So that would be a negative 6x and a positive 12y. Commutative property. Commutative means moving. So it says you add or multiply two numbers, does not matter, the result will be the same. Commutative property of multiplication means switching the numbers. Switching the numbers around. The result will be the same. That's commutative property. The results will be the same. When you take A plus B and make it B plus A, that's going to add up to the same amount. If I take 5 plus 3 and change it around to 3 plus 5, either way I'm going to get 8. If I take A times B and make it B times A, I'm going to get the exact same answer. If I take 5 times 3 and make it equal 3 times 5, they'll both be 15. You could switch numbers around and it does not change. So if I had 6 times B, then I could put B times 6. And that would still be the exact same thing. The B right here. At the bottom, commutative means the terms travel or move, which means the order changes. Just the order changes. The value does not change. They have the same amounts. Same amounts. And the last slide is the associative property. And what happens with associative property is the parentheses change. When adding or multiplying numbers, the order in which you group The order in which you group the numbers does not matter. So you could put down here the parentheses change. Parentheses change. Like here, this first one. First one, you have A plus B in parentheses plus C. You could move the parentheses to B plus C and have the A on the outside. You're still going to get the same answer. If I did 2 plus 5, got 7, and added 3 to it, that's going to give me 10. If I do 5 plus 3 and get 8 and then add 2 to it, I'm still going to get 10. So the parentheses moved from the first two to the last two. Notice the order, 2, 5, 3, 2, 5, 3. The order never changed. A, B, C with the parentheses around the A and the B. A, B, C with the parentheses around the B and the C. The order did not change. So they stayed the same. And then 2 times 5 with the parentheses around the first two gives you 10 times 3 would be 30. Or you could do 5 times 3 is 15, and then times it by 2, you're going to get 30. So either way, the answer is the same. The only thing that changes are the parentheses. They move. So associative property means the terms associate with other terms, but the order does not change. Commutative property, the order changes. Associative property, the order does not change.